So with something like question 7, right? We can see it's a 2D, 3D triangles question, like point blank, That's what we can see. Now it says question 7, right? Question 7. A rectangle box with lid A, B, C, D. So this is a rectangle box. The lid is A, B, C, D. This lid is given in the figure below. And then it says here the lid is opened through 60 degrees to position HKCD. So you can see how I'm reading this question. I'm reading it in installments. I'm reading it like almost like a grade 1 learner, because it's not something you really just want to read and just brush through and like be gone and start answering. No. Everything you read, especially with something that has like some kind of a sketch and it's like a real life sketch. I mean, like in the world we live in, I mean, like there are rectangular boxes everywhere that have lids. So with most of these questions, you want to think rationally and you want to think logically. You don't want to just think that it's a fake scenario or something too hypothetical or whatever. So they're talking about a rectangular box. It has a lid. This lid opens, and fortunately we have like some pictures to help us with that. This lid opens, and they said when it is opened, it opens like at an angle of 60 degrees. So fortunately there's a sketch to help us there. Okay, so that angle there is like 60 degrees. And then it says yeah, it's angle of 60 degrees as shown in the figure below. And then it says yeah, EF is 12. So where is EF? EF is 12, FG is 6, and BG is 8. So they've given us the dimensions of the box, which is dope. Now, for 1 mark, right? They said write down the length of KC. KC. Where is KC? KC. Okay, so if we're looking at our 3D sketch, I want us to write down the length of KC. So writing down the length of KC, I mean, like, don't overthink it. Getting the length of KC is something that you want to do confidently. Now with a 3D image, right? Like, don't limit yourself to what is like on the piece of paper. What I mean is, if you're going to work out the distance of KC, right? The best thing you can do for yourself is to just think of yourself as though you're looking at this rectangular box from the right hand side. You see, if you're looking at it on the right side only, you will be seeing something like this. There will be K up there. It goes down to C. There's like K there, right? And then there's point C over there. And then there's like point B somewhere there. You see, this is what you're seeing when you're looking at the image from the right side. And then here you're probably gonna see there's like F down here, there's like G down here. Those are the relevant things. Now what they have told us is that this angle here is 60 degrees. You see, they're asking for the length of what you may call of KC. So logically speaking, this is the lid of this box. So this lid was closing this distance here. So meaning if this distance here is like a 6, this lid is also just 6, you see. Excuse me. Yo, ek is jammer. Ek is jammer, mensen. So that's the whole idea with this 1 mark question. I think even me, the way I was busy talking about it, I kind of made it seem like it was something, but it's really not. It's a 1 mark question. The lead is the same distance as this part, so it's just a 6. So let us just move on, really. And then it says here, for 3 marks, right? Determine KL, the perpendicular height of K. So they want us to get KL. So I think this right view picture is gonna help us now, because there's K up there, right? And then they want us to get the perpendicular distance of KL, because L is the point down there. If you're looking at the picture from the right side, what we know is this is 6. What we know is this distance here is 8. Whether that's going to be helpful, it probably is, So if they're saying this is a perpendicular height, let's see. Determine KL, the perpendicular height of K, above the base of the box. So the fortunate thing is, as we can see from what you may call from K until this point, right? That's all we need to get, actually. That's all we need to get. We just need to get this distance here. And then once we get this distance, we just need to add it to 8. So with this, without me like beating around the bush, right? I'm like, we just can just focus on this portion of the sketch. You can even draw a right angle triangle here, where there's K here. This point, we don't have anything labeled for it, but it doesn't matter. And then this is like 60 degrees, right? This is like 6. So you have 6 here, you have 60 degrees here, and you need to get this, you see. So you can just use normal trigonometry. You see, opposite over hypotenuse is what you need, because you have the angle 60 here. So you can just say sine 60 first is equal to opposite. You don't know what this distance is, you can just use any random variable. You can use x because there's no x anywhere here. It's just going to be opposite. You can even write opposite if you want, you know, maybe if it'll make you feel better. Opposite over hypotenuse. I'm just literally being extra here because all this is very unnecessary. Opposite, we don't have anything for it. Let's just use a variable x. Hypotenuse, we know it's 6, and then this is sine 60. I'm literally just writing. Yeah, let me get on. Solving for x here, multiply by 6 here, multiply by 6 here. We have 6 sine 60. This is equal to x. In our calculator, this is like 6 times 0. I was about to lie hard. Way too hard. Hey, let me grab my calculator because, hey, why think when the calculator is there? You know, this calculator must work. It works full time. So sine, it's 6 multiplied by sine 60, which is like 3 square root of 3, right? So the answer here is 3 square root of 3. 3 square root of 3. That's the x value. So don't get carried away and then just leave that as your final answer. Nope. They want the whole thing. So you have 3 square root of 3 here. And then you have the distance of 8 there, you see. So the height KL is going to be 3 square root of 3 plus 8, of which you can just leave it like this. You don't have to, what you may call, you don't have to do what? You don't have to like put it as a decimal, nothing like that. You can just leave it like that and get your 3 marks. So let us keep it moving, yeah? For 4 marks, what did they ask for 4 marks? They said hence, the big H word. I feel like I cannot say this enough, obviously. I mean, you obviously probably know what is coming. Anytime they say the word hence, they definitely mean that you should make use of what you have just solved, or make use of what you have just figured out. Not just the previous question, but literally almost everything. So the funny thing is, it's literally just a courtesy when they use the word hence for a question, because most of the time, 99.99% of the time, questions they just fall on each other. It's like a snowball effect. One question leads to another, going on and on. So they say that we need the value of this expression. So what you should not worry about is how this is a fraction, how they sign on top, sign at the bottom again. No, that's not what you should worry about. You should just keep it simple. Keep it simple, keep it light, and keep it moving. But anyways, what I'm trying to say is let's maybe have our sketch down there. I think having our sketch down there is going to like help us a bit, because like scrolling up and down, it's not the way, man. It's not the way. We just want to have it close by, because why not? So we have our sketch here, and what matters is, you know, the dimensions of our sketch and all that. So, and they're talking about K and D, blah, 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 blah. It's like, so they say determine the value of this expression. So whatever you're given, remember we said in this question up here, don't just get a question and only use what you're given. No, 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 no. You get something and you make it your own, you know? It's like what? What's the analogy I can use? It's just like having, I don't know, a house. You buy it empty and then you make it your own by putting whatever furniture you want. That's it. That's not a very good example, but I think you get the idea. So here, the idea is what you're seeing here. I just break it up slowly but surely. So they want us to get the value of sine KDL. So the first thing we can do is let's get an expression for KDL. We need an expression for KDL. We don't have it. We need an expression for DLK. DLK, we don't have it. You see, two things we don't have. That's fine. But the things you don't have are the things that help you get the things you want. You know, it's kind of weird. You can't really want something unless you don't have it. So low key, the things you don't have are the ones that help you get the things you want. Blah, blah, blah. So one thing is, let's see, KDL. Where is KDL? KDL is an angle, right? So let's see where that angle is. There's K, there's D, there's L. Now don't get sidetracked. KDL is this angle here. KDL has nothing to do with this angle there, and it has nothing to do with this angle there. They're not in the same plane. Like, don't even think they are. You almost want to look at this triangle here as though it's in its own plane, because it is. This is a 3D sketch, right? So you have a triangle here, and one or the other in this triangle, the only thing we have is the distance of KL. You can imagine why the question started with hence, you know. And the other thing with the 3D image is, it doesn't matter if it's a 3D image. All the questions you will ever answer, you will always be using a portion of the sketch that is not, you'll always be using 1-2D surface at a time, you see. So for example, when we were working out what we were working out in the previous questions, we were focusing mainly on this side of the image. So with now, we are basically just focusing on this specific triangle. You know, not much really matters, because there's K here, there's L here, and there's D over there, right? And then KL is 8 units. No. 3 square root of 3 plus the 8. Mistakes. They are already happening. This is the only thing we have so far. And yeah, it seems a bit, it's quite interesting. But the fortunate thing is, in as much as we only have this KL here, right? Funny enough, if you really look nicely, right? We have this distance here, and the angle KDL is this angle here. If you look at this sketch creatively, remember they said that H, K, C, D, this is a lid of our rectangle. Now you're looking at a 3D picture. Don't get sidetracked by the fact that this is a 3D picture, because in as much as this is a 3D image, you have to remember that this shape is still a rectangle. Meaning, if you were looking at the shape from the top, what you know is that this angle is 90 degrees, this angle is 90 degrees, this whole angle is 90 degrees, this whole angle is 90 degrees, because it's a rectangle. You know, all 4 corners of any rectangle will always equal to 90. But then we're looking at this as a 3D picture. So obviously when you're looking at it, I mean, you may argue that, but wait, it doesn't look like 90. Of course it doesn't look like 90, because it's a 3D picture. This is where you need to use your imagination, you know. All these corners here, they're 90 degrees. So the reason why I'm emphasizing that is because in as much as we have this 3D picture, right, it looks as though we have enough information to get the length of DK. If you look at the length of DK, firstly, we have HK, right? HK is 12. You see, if this is 12 here, this is also a 12, and then this is also a 12, because it's just a rectangle. You know, this is a 12. And if this here is like, we got this as what? I think it was 6. If this is a 6, then this will be a 6, then this will be a 6. Meaning this is also going to be a 6, you see. So in our sketch, we have this triangle here that can get us the distance of KD, you see, because we have K, D, H here, right? This is 6, this is a 90-degree angle, this is 12. So apart from us just clinging on to like what they're asking, what we don't have, blah, 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 you're always 100% welcome to get your own items onto the sketch. And it looks like before we can even worry about doing anything about getting an expression here, we definitely need more information. And the only piece of information it looks like we can get for now is the length of dk, and it looks like Pythagoras theorem is gonna save us, you know. So dk squared, we know it is equal to 6 squared plus 12 squared, meaning that dk is technically equal to the square root of 6 squared plus 12 squared. So let's see what dk is. Dk is equal to, let's see, square root of 6 squared plus 12 squared, right? This is going to give us 6 square root of 5. This is giving us 6 square root of 5. That's the distance of dk. So we might as well put that there. 6 square root of 5. So it looks all nice and dandy. It looks like it's things are moving. It kind of does look like things are moving. To be honest, the way this looks, it kind of looks a bit scary and a bit strange. And even me looking at it myself, I'm like, doggo. I mean, everything makes sense, right? It really does. It really does. But then when it comes to you know, like a 3D image and all that, like those are some of the things they can really like mess with your head, and they really can, you know. So I'm trying to not take anything from the fact that these questions, yeah, if it, like literally now, right? Let me do this so that we don't like waste any recording unnecessarily. Anyways, so with what we have so far, the one thing that we mentioned was the following, right? We have another angle in our triangle that we are dealing with. We're dealing with also DLK. So the funny thing is, normally this is one thing I've seen sometimes in memos, right? If we have scenarios where there are too many things that are like left out, usually the memos just use what they have. And then sometimes things usually end up canceling out. It's usually always weird. But then the fortunate thing is, I feel like you have a point, Chloe, because if you look at our sign rule, right? Okay, let's use the variables we actually have here. We have L here, and this is going to be small l, technically speaking. So let's put here angle L and then small l. And then here, let's put here angle D and then the smaller version there. Let me put that there. So this, we can just, I think our sign rule might help us, because if we think of the sign rule, right? The angle here and the angle there. Firstly, L here is just DLK. So here we can say sine DLK over the opposite side, right? Which is like 6 square root of 5. This is equal to sine. Angle D here is representing KDL. KDL over the opposite side, which is 3 square root of 3 plus 8. So they want us to have a ratio where this is over that, you know, so we just need to end up with this over that. So that's actually not going to be very difficult. Like, wow, look at that. So from here, I'm just running out of space here. But then from what we wrote down, right, it looks like we're home free, because what we can do first is to like cross multiply, right? You just multiply this with that, multiply that with that. It's going to give you 3 square root of 3 plus 8, the whole thing multiplied by sine DLK. Here you have to use brackets. If you don't use brackets, you're going to flop. And flopping is not allowed, you know. When you're on the roll, don't flop. It's not good. This times that is going to give you 6 square root of 5 multiplied by sine KDL. So the fortunate thing is that we just want sine KDL on top. So if you want sine KDL on top and this at the bottom, I mean, like, it's just you doing normal algebra. So you're gonna just divide both sides here by sine DLK. These cancel out. And then you also do the same here, sine DLK. You see. So what you're gonna have here now is 3 square root of 3 plus 8 equal to 6 square root of 5 with the sign KDL here over sine DLK. And then we can just divide both sides by 6 square root of 5. So this side here we can divide by 6 square root of 5, divide by 6 square root of 5. So you're gonna have here 6, 3 plus 3 square root of 3 here plus the 8 on the top. You come on, bro, right nicely. 3 square root of 3 plus 8 is gonna be at the top. This you're dividing by 8, so it's gonna be at the bottom. And then since on the right side you divided by 6 square root of 5, I mean the 6 square root of 5s cancel out because this cancels that because you're dividing, and then you're left with sine K D L over sine D L K. Whew, 4 marks. What a wow. So that was interesting. The cosine rule came to the rescue. So yeah, I said already, Chloe for president. So that's the big idea with what you may call with these kinds of questions, right? You wanna just follow your intuition. If you're going to beat around the bush and not do something, yeah, that's not good. You might as well do something, see the memo, and then correct yourself. Other than maybe not doing anything at all, see the memo and feel discouraged for not doing anything, you know? So anytime you do something, you know, from your own intuition and you check the moment you see it's wrong, don't feel bad or feel dumb or whatever. No, I mean, like, bro, you're learning. The crazy thing with people when they're learning something is that when they're learning it and they see they don't get it, they forget that, wait, you're still learning it. You don't know it in the first place. It's not like if you just look at something 1 or 2 times, it's automatically gonna jump into your head. That's not how it works, you see. You need to be comfortable with going through the time period where you don't know something for you to eventually end up knowing it, or for you to eventually getting comfortable with it. So just be free to try stuff out. So even here, the whole sine rule thing, I was even reluctant to do it because I was like, nah, there's not enough information. But then in as much as these two are both open, they are both, you know, something that we need. So I think this was a good question. It was really, really a good question.